Sarvesh. This is my video demonstration for the production ready LLM fine tuning with LoRa and Hugging Face. The objective here was to build an end-to-end MLOps pipeline to fine tune the Mistral-7B instruct model using parameter efficient fine tuning, specifically QLoRA, and then deploy it as an API. Now you can see the docker.compose.yaml file. First, let's look at the infrastructure. I containerized the entire project using a unified Docker file in my docker compose.yml file. I have defined two distinct services: training service resources GPU for our fine tuning scripts, and the API service exposes port number 8000. Notice that I also successfully implemented the required call health check for the API container to ensure the robust deployment. Now we'll come back to the root folder, and this is the Docker file I implemented. Now, since this project needs significant GPU RAM, since my laptop is only have the requirement 4 GB RTX 3050 GPU only, which is developed by the NVIDIA. It's not efficient not sufficient for the for this project, so I used the Google Colab notebook, which gives the virtual RAM for free. I used the T4 GPU on Google Colab to run this project. Here is the first step. First I unzip the whole files which I uploaded here is the project directory, and I give the environmental variables and Hugging Face model and WandB API key and base model, which is using Mistral AI Mistral-7B instruct version 0.1. Then I prepare the data. This is the first time data preparation. My script downloads the Databricks Dolly 15K datasets, cleans it, and meticulously formats its strict JSON. I will show the script now. This is the prepare data.py, which loading the Databricks Dolly 15K dataset, cleans it, meticulously formats it into a strict JSON array, where the instruction context and response are combined into a single training prompt before splitting into 90 by 10 training validation set. Now I'll go through run training.py. This is the run training.py. Next is the core training loop. I used the bits and bytes config library to load Mistral-7B in 4-bit precision to save memory. I then configured a LoRa adapter targeting specific attention modules. My script utilizes Hugging Face SFTTrainer to fine tune the model, automatically logging the metrics to weights and biases. Once finished, it successfully exports the adapter model.save tensors and config files into models directory. One sec, I'll show. Switching on now. This is the adapter model dot safe tensor. Safe tensor models. Finally, I'm going through the evaluation metrics dot the results to prove the model actually land my evaluation script calculates both qualitative and quantitative metrics. Here in the JSON files, you can see the required rows LF measure is correctly formatted as a nested object alongside perplexity and blue. Perplexity and blue. Moving the Markdown file, here are the three qualitative examples from the validation set comparing the base models and output against my fine-tuned model. I'm switching to the comparison.md. These are the prompt and the base model output and fine-tuned model output. Now I'm switching to the main.py. Finally, the last stage of the pipeline is deployment. I built a fast API application that automatically loads the base model and stitches on our newly trained LoRa adapter. It exposes a get slash health endpoint for Docker container checks and post as generate slash generate endpoint utilizing pydantic slash generate for pydantic schemas to accept your prompt string and return the generated text. Uh, Thank you for taking the time to review my full MLOps pipeline. Thank you.